Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find meeting information posted at meetup.com at the URL listed below. We'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting raffle prizes, which will be given away using the evaluation forms. Also like to thank the .NET Foundation for sponsoring the cost of the meetup site, and NIS Technologies for sponsoring the meeting space. We have a special offer from Manning.com. If you're joining us for the first time, they offer a 35% off using the discount code MTPCLEC21. The selection of books is available at the link listed below, and that will be made available in chat shortly afterwards. Some general information, like I always say, participation is always encouraged, and the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to prevent any background noise. And we always like to keep it casual but organized, meaning we want to give enough time for our speakers to go through the presentations, the slides, and the demos. But at the same time, casual enough where you can jump in with any questions or comments. The meeting will be recorded and will be posted on YouTube within a few short days. And if you join or subscribe to the website, you'll be able to get notifications when new videos are uploaded. And again, that link will be made available later in chat. So for tonight's feature presentation, it's going to be C# 11 by Mads Torgersen and Dustin Campbell. Mads is the lead designer of the C# programming language and the program manager at Microsoft. Dustin Campbell is a former Findlay resident, is the principal software engineer and language designer at Microsoft. So you guys are presenting for the second year in a row in January, and we're very glad to have you. And with that, let me turn it over to Dustin.
Very happy to be here. Now Dustin is clicking buttons to show his screen, and I don't know if he can walk and chew gum at the same time, so I was going to take the lead on speaking until it's up. There it is. That looks beautiful, Dustin. This is we don't do slides anymore.
Yeah, we have crafted kind of one would say we've gotten down to the essence of what the talk really is, and really got down to really just distilled it into kind of perfection, which means no slides. But really, we've gotten lazier, and found that they weren't worth it. They weren't worth the headache. So we don't need slides. We just want to show code and talk.
Wisdom is where laziness and excellence.
Yes. It's a very fine line between laziness and excellence, right?
Yeah. So we did a thing. Like clockwork now, every year a new version of C# drops in November. And this time around, we were up to C# 11. Even for us, it's getting kind of dizzying that we have a new major version of C# every year. I find myself struggling now remembering which version features like records or indexers or stuff like that are in. Because there's more, there's a quicker cadence there. Mm-hmm. And we've done that for a few years now. We've kind of settled into it, and apart from struggling to remember what happened when, we're actually kind of enjoying it because we get to, we're already open source, and we have a very active community. We interact a lot, get a lot of contributions, but there's also there's a very important feedback loop in shipping something and getting usage on it, and then iterating, and being able to do that every year, I think, is really something that we're starting to find a lot of value in. So this year we have some brand new features, and we have some that are sort of like the next step of some existing features that have been around for a few releases. So, Dustin, tell us what's on your screen.
What's on my screen? Well, it's kind of typical demo fodder, right? We're language designers, and so we generally have just real simple snippets here to kind of demonstrate what we want to talk about. And so we've been, and with these releases, as they've come to an annual cadence, we've had opportunities to, instead of kind of focusing on one big feature, really hard for like 3 years and put it out there and it's totally complete and perfect, right? Think about like Link is kind of like a beautiful example of that. But now with these annual cadences, we tend to refine and continue to add polish or add kind of scenarios and things to features that we're shipping kind of, in not, I don't want to say in pieces, but we ship features that complement the things we've been shipping before. And so this particular demo that we have is, it's a person class. We've done this before. We probably did it last January. It's got a couple of or three init only setter properties on it. So these can be set at construction time. They're essentially read-only properties that can be set at construction time or from within an object initializer. So either through a constructor or an object initializer. So, and of course we've got a question mark on one of the nullable reference types there on the string to make it a nullable reference type. So we're fully C#8 and above here. And that's that's what we're looking at now. There's a couple of problems with this. And it's something that if you started playing around with, say, records, which this is kind of a record. We didn't say record, but it's very similar to that kind of data type. But you wind up with these warnings in here, and it's the first thing you run into, and it's kind of quizzical. And they force you to do kind of awful things, right? So for example, I want to show this warning up. It says, now I've got these inner-only properties that are basically read-only properties, essentially, with a little bit of extra kind of spin on them. But
Dustin, can I interrupt you for a second?
Yeah.
Are you hovering on the warnings?
Oh, you can't see that, can you? No, never mind. Yeah, so I can't see the warning. Well, let's quickly pop up the error window. Interesting.
I think when you share your window, apparently the
pop-ups I can't see the warning. That's okay. That's okay. So there's two warnings here. One that the first one is that the non-nullable property, because it's marked as it's non-nullable by virtue of not having a question mark, must have a non-null value when exiting the constructor. So consider declaring it nullable. But in this case, that's not our domain, right, Mads? Now we can interact. Sorry, Mads. I was hovering and gesturing for you, and you were like, huh?
Yeah, and also your arrow window isn't showing either.
Are you serious? Is it? You see typing? Typing in it. Uh-oh.
Oh, maybe it's. I don't know. I don't see typing either. Oh, is it me or is it everyone else seeing this or?
I assume it's everyone.
Yeah, I don't see any typing either, or the error window.
Wild. Okay.
Now the error window showed up.
Okay. Well, let's.
Maybe.
How about the typing? Okay. Yeah. No.
Still no typing.
Oh dear.
But your cursor showed up.
I know. I'm looking at it over here.
I see your cursor, but it's not moving.
Oh dear. Yeah. Well, that's a problem, isn't it? Any ideas of what to do? I'm just sharing this window. I guess I could, let me try. Let me try one thing here. I'm going to try and fix this real quick. We'll try a thing. So I'm going to take my window and I'm going to maximize it up on another monitor. So I will be looking up as I type. So forgive me for not looking at any of you. Well, I'm going to try sharing that as a screen. And let's see if that does the trick. Okay. There we go. Now it seems to be working.
Yeah.
Yeah.
Now it's working.
Okay, but I'm going to be looking up because I have this magnificent monitor, 2 monitors up here, and then this 49-inch bad boy down here. So forgive me for looking up while I type. But
you got a beautiful chain. Go for it.
Yeah. Okay. Well, why don't you go ahead, Mads, and continue on? Since I'm kind of.
Yeah. Let me see if I can rewind to where we were. So yeah, if you can hover on those warnings.
Yes.
Let's hover on one of those. So essentially, we did nullable. We're very happy with it in many ways, but it does have a little bit of a sort of it doesn't fit completely well with the object initializer approach to object creation that we are also trying to further, right? And that's what these warnings are showing, that, oh, you have a nice non-nullable property there, and I can't see inside of your class declaration that you're initializing it anywhere, so it's going to be null. So
Right.
non-nullable that's null. That's not a good thing.
Because we're trying to do it up here, this object
warning.
initializer. Yeah. So what you end up having to do is shut these things up. Right?
Yeah.
You know, doing things like this. Well, that just moves the warning around.
But now we can catch it in a mousetrap.
Yeah, now we can do that. Ooh.
Yeah.
Or maybe something sensible like this, put a string.empty or something in there. And that gets rid of the warning, but that's not actually what we want, right? We want to have the invariant that our object has, that our class, when instantiated, has a first name and a last name and optionally a middle name, right?
Yeah.
So it's not.
It's sort of like it's one of those things that constructors can do that object initializers can't do. Constructors can force you to provide certain values. And we would like to allow object initializers to do that. We would like, essentially, for properties to be able to be required. Like, you can't create an object without giving a value to this property. And indeed, apart from the semicolon, yeah.
There we go. Now I have an error.
Yeah, the warning went away, but now you have an error.
And the error is that, that I now, because I've said that last name is required, it must be set in the object initializer. And so we can come up here, we can provide a last name, and now everything's great, right? So we're using nullable, we're using iter-only properties, we're using object initializers to construct things, and we are guaranteeing that our objects have a valid state on construction, even when done with object initializers. So again, it's kind of a feature that complements existing stuff we've been releasing over the past several years.
It bridges them together in a way. Yeah.
Yeah. One other thing is kind of interesting. The error that was up here before I gave it a last name mentioned attribute constructors as well as object initializers, right? And that's because attributes, even though they were introduced with C# 1.1.0 back in the day, right? Back before you and I were working on the language, really. But that's a feature that has like properties that can be set sort of like an object initializer, but within the constructor, right? For an attribute. So if I were to like make this an attribute, I could, very easily come in and say, okay, person, and you see there's the properties that I can say. Well, I could say first name. Oops. But right now, this will also give me an error, just like the object initializer did, because I haven't given it a last name yet. So again, we're making these features that complement features that we've put in recently in the last few years, but also all the way back to C# 1.0, we're making sure that these features compose nicely together. So that works too.
Yeah. One thing you might be wondering is, that sometimes you like having constructors that do, in fact, initialize the whole object, and maybe you want to let people choose, do they use a constructor, do they use object initializers? Sometimes you have constructors for other purposes, like a copy constructor, and that does indeed initialize the whole object. And so for sort of that advanced scenario, if you will, of multiple constructors, where some of them do initialize the whole object, we do have we didn't give it syntax. We have a little attribute that you can put on a given constructor and say, don't you worry about this. When people call, that's required. This constructor does set the required members. So don't give an error when people call this constructor on this object. Only when they call the ones that don't say that they take care of it. We don't check it in any way. We just take your word for it.
Yeah. It's kind of an escape hatch. Yeah.
Yeah.
Cool. Well, that's kind of our warm-up feature. It's just
It
it's a
is.
welcome feature. It really does round out kind of the record story and the init only properties.
So are you all warmed up? Do you have some questions or um, there was one there that says required is the new keyword. Yes,
Yep.
that is a new keyword.
And I don't know if did you mention it, Mads? We did do all the extra work. We're not showing it here, but yes, this does work with inheritance hierarchies and all of that as well. So
Yeah, I didn't mention
again,
that. Yeah.
trying to make sure that it's composing nicely with everything you already do.
Yeah, of course, if you inherit required properties, they're also required for when your constructors are called. Right? Requiredness is inherited. Yeah, feel free to post questions in the chat or come on.
Hop on, say hi.
Hop on with or without the camera and ask just along the way as well. We're going to try to pause for questions here and there, but also just like kind of wedge in if something's on your mind. We're fine with that. We'll make sure. I think this invite that we have is for an hour and a half, and unless Sam says otherwise, that's roughly what we'll go for. So we'll try to make sure that we got through our material another hour and 10 minutes from now. But other than that, fire away. Yeah, go ahead.
I have a quick question. Sorry, I actually had a call I had to take, so I may have missed it. Hopefully I didn't, but I'm curious about the required. Is that something that dovetails into but my brain is evading me now. Mapping, ORM mapping, when I'm mapping this to a database object, those required attributes, or is this totally separate?
It could. I don't know if I'm not actually up on what, for instance, the entity framework, if they use this.
But yeah, actually, the entity framework was what I had in mind in that question. Yeah.
Right. Yeah. No, there are. There's metadata generated for requiredness so that we can, so that the C# compiler can spot it across assembly boundaries, and other frameworks should be able to pick up on that either through reflection or compile time tooling.
Yeah. In fact, the sets required members attribute that we discussed is kind of critical for that scenario where, it might be constructing an object that then gets totally actually realized its fields and its members and data from a database, right? And so the actual properties might not get set directly in the constructor, but they are set logically during construction time, whether that has to do with being serialized from a database, deserialized from a database, or whatever. So we did try and put the features in to make sure that is ready to go. I don't know that any framework has taken it yet. It shipped in November, and that's actually one of the the problems, I would say, or maybe just one of the niggles of having an annual cadence, is that it is hard sometimes to produce language features. Sometimes we're working on them to the very end in that annual cadence, and sometimes they don't make their way into the frameworks, the libraries until a little bit later, until a little bit more time has passed. So depending on where it falls in our schedule over the year.
Yeah, that's a good point. You often, just like you see a language feature maybe get adorned or grown in subsequent releases, you also sometimes see the rollout of the usage of that language feature take a release or two throughout the rest of the framework. For instance, the various samples out there and so on. It's a little more, you get more sort of intermediate state in the shipping profile, if you will. It's not the pristine, everything has been thought through and everything set in stone that it was a decade or a decade and a half ago.
Yeah, and to directly answer your question, Michael, because we were kind of dancing around a little bit, we don't know.
Yeah.
but we made it so that it would be so, that it could be so. Yeah.
Thank you.
Yeah, right. If I could interject real quick, I just saw a video by Nick Chopsis. you guys are familiar with him. He's excellent on C#. But anyway, he discussed how a lot of these recent features and additions to the language are enforced by the compiler and not the runtime. In many cases, he described them as syntactic sugar. And where that's relevant to Entity Framework is it would depend how Entity Framework actually populates. And I haven't used it in a while, so I'm a bit rusty. If Entity Framework does code gen, then it would be compiled and enforced. But if it uses reflection or like some other sort of code gen that like IL, a lot of ORMs use IL under the hood, then I would imagine that Entity Framework would not respect these required keywords in your source. So does that make sense?
It does. And you're right that there's a difference. And this is actually not just the new features. It has always been the case that there's a difference between the level of protection the compiler gives you at the language level versus what's enforced at the reflection level. Once you go into reflection, you're sort of, you're empowered to do more things. And an example all the way back from C# 1.0 is read-only. Read-only is not enforced at runtime. You can actually just go and use reflection to assign right on top of something that's read-only. That's always been the case. It surprises some people, but many of these rules and restrictions are language level only. However, in order for them to work even at the language level, we do need to encode them in IL. We find some way. Sometimes IL has specific bits that we can use for that purpose, and it's kind of shared across all the IL languages. And sometimes we stick an attribute or modopt or modrec. There's some other kinds of extra metadata you can shove in various places. And we use that to communicate between the various, like when the compiler reads metadata. But it also gives an opportunity for other tools to plug in. And a lot of this can also be, these things can also be dug out through reflection, this metadata, if you know what to look for. So as long as it's fragile because the compiler doesn't really like document or even promise to stick to its emit strategy, if you will. So in principle, we can change, and occasionally we have changed how we emit some metadata when it's not visible at the language level. And then some reflection-based tools or IL-based tools have to scramble to then understand the new format that we've made. So we only do it if it's kind of really beneficial to the end user, but it's happened actually. And so there is an opportunity, but it's not something that is officially supported, that is spec'd and has like guarantees around it. It's something that you do at your own peril, like most reflection is, really.
Thanks.
All right, shall we move on to our next trick?
One question just came in.
Oh, sorry. Yeah.
Would using required check the value? For example, could I say new person, first name equals null, last name equals null? If yes, this isn't strictly for ORM validation. It required doesn't check the value. Required just checks that a value is provided. But if Dustin puts null there, then the null check, the nullable reference types feature will check the value and give you a
because
warning.
This is not defined with a question mark like middle is, right?
Yeah.
So this one says, nope, this is non-nullable. We expect that you can't put a null literal in there, which I can shut up if I really want it to be like that, but I don't.
No, it's better to listen. And which is actually like when a feature like nullable has warts like the one we just dealt with here, it's really worth it for us to go after those and try to eliminate them, because most places nullable is it's quite reliable. It's not ironclad to any level, but it's quite reliable. And if it's wrong in too many places, then people start taking less advantage of the warnings they get and being more more prone to just shut it up. And that's really a shame. Like the feature is there to be useful. It's there to tell you about real problems. And now here's another big, probably by far the biggest scenario we had left where it was kind of wrong, or it was inadequate, if you will.
Cool. All right, let's move on to the next piece. This is a fun one. Do you wanna set this up?
Sure.
What do I got here?
What you have here, there is an extremely advanced numeric algorithm. It takes an array of ints and it adds them up and returns the result. So it's numeric. So the point about it is, this is something that you could imagine doing again and again for different types.
You want this for, I don't know,
doubles?
Yeah,
just
we get
doubles.
very used to copying and pasting these things around, right? So that we can do that. Of course, I can't do that at the top level here because local functions cannot have overloads.
They cannot be overloaded. So too bad. But the point though is that you couldn't really write a sort of an abstracted add method, that add all method that does those things abstracted over which numeric type it had. Wouldn't it be great?
You couldn't make this generic, right?
Yeah, but it'd be, and so lots and lots of overload exist in the world, either overloads or lousy, terrible abstractions over math that are like instant in terms of instance methods that you have to resort to.
Look at all these guys.
There's so many. 13 overloads of math and max. There you go.
Yeah.
So what would be really cool if we could do abstraction over them by generics? We don't want like subtyping isn't good. We want it generics because we want to hold on to strong typing here.
Yeah. Instead of saying int, I just want to say t everywhere, right?
Yeah.
And as you can see, we still haven't made that work.
That doesn't just work because how would it know that t is a number type?
It's an unconstrained generic, right? We would need to constrain t to something, right?
Or t is something, like say a number.
Yeah.
And
so there's now an I number that takes t self, which I'm going to fill in with t, meaning, this is for myself, is what it means.
Yeah. T is a number that does math on t's.
Yeah.
That does math.
What's cool? And what's cool is that if I take that back off, there's an error on the operator because I can't apply operands to t and t, but as soon as I constrain it to I number, well, now I can.
Yeah.
In fact, if I hover over, I can see, if you can see that, it says, it comes from another interface called I addition operators that take an operator plus returning t and t, that takes t and t. That I still have an error on the 0.
Zero really isn't it? Yeah.
Yeah. Because I know some of the language rules, and this literal 0 is always an int, right? And then it has to have a conversion, but there's no conversion of int to I number of t, right? Yeah. So we need some way to find that 0.
Yeah.
So
but when you think about it, go ahead.
Yeah. Go ahead. And I can find all sorts of members on t because I've constrained it to a t that's a number. Well, on here, and it tells me it gets the value 0 for this particular type.
So you can actually there's some static members there that you can get at. And when you think about it, the plus operators are also static members. So apparently we can use generics to get at statics now. And it works. So let's just check, does it actually work for doubles as well?
It's a great idea. So if I want to make a double.
Really abstract it?
Yeah, because right here, so we're kind of being kind of clever. We didn't put new int here. We're letting it, the best common type algorithm in the compiler, decide that this is actually an array of ints. But if I make one of those a double by just putting that decimal there, now this is going to be inferred as a double array, which means then add all is now generically passing in doubles, and so it adds up doubles. So t here, all of these still work as expected because they're generic operators and members coming from the t that's constrained to I number. But if I run it, Now the answer is, and I'm sorry if that's too small, that's 12.3. So
Yeah.
it did. It added doubles by virtue of passing an array of doubles instead of an array of ints. It works.
It does. And
People
it
have been
looks
asking
like
this
it's all.
since .NET 1.0.
What's that?
I said people have been asking for this since .NET 1.0.
Yeah, since
For
before
generic math.
generics was in.
Mhm.
It's pretty amazing.
Yeah.
So yeah, 10 versions later of the language. So the magic though is in that iNumber interface.
Yeah.
Somehow.
I'm going to go to definition on this guy so we can see him in here. And close these windows. We don't need these. There. Oh, sorry, Mads. I have the wrong thing on. I have decompilation on here. Let me turn this feature off so we can get a better view of it. And if you don't know, in the advanced page under C# and options, there are all sorts of things on go to definition. And I don't want to see decompiled sources or embedded sources or source link because it's showing me everything. What I want is the metadata as source view. There we go, where it kind of shows you kind of a trimmed down view of the shape of the type instead. And what is fascinating to me about this, Mads, as we look at this particular editor, and it might be harder to see, but just look at how small the scroll bar thumb is all the way at the bottom. It's just itty bitty because there are so many interfaces now that are implemented on this thing. It just goes and goes and goes. And this all comes, all these interfaces compose to make up iNumber. It's pretty amazing.
Along with those extra members that are on there directly, yeah.
Yeah, so if we go to the iAddition operators that we saw earlier, come down here, and we'll see where our operator members came from, the pluses, the plus equals that we used earlier. And the exciting part about this is that we actually have static members, static abstract members on these interfaces that we're now able to implement on types and say, hey, this type implements this interface. That means it has these static members. That's something you could never do before. It's kind of, I like to think it's a big deal.
Yeah, so. And that includes operators, of course, but also we saw the 0 before is also a static member that some interface somewhere in this large list has said, well, there's a 0 property. If you're a number, you have a 0 property. Statically, you have a static 0 property. Mm-hmm. So yeah, it's really a new abstraction mechanism, if you will. It's a new this one is kind of deep, right? You can really express new things. This is not syntactic sugar, to go back to that Nick Chapsa's comment. This is like deep expressiveness all the way down into the runtime that wasn't there before, that you couldn't kind of fake very easily, and now it's there.
Yeah, I remember wanting this back in C# 1.2, I think it was, days. Back when I started using C#. I mean, but yeah, this is a new abstraction, and I mean, to really put it into perspective, this would be the first real new way to abstract over things that we've introduced to the language probably since generics in C# 2.0.
Yep.
Yeah.
It's kind of mind-boggling.
It really is. I mean, you've been able to do things, and we've been able to go very far with generics and introduce lambda expressions and all of that, and really go pretty far with that. But this one is truly new. We couldn't do this in syntactic sugar, right? It has to be baked in at the runtime. So that's pretty awesome.
Yeah. So now we're here. Before we move to another interface, a couple of things I want to call out here. First of all, well, I forgot what the first of all was, but the first thing is the language feature that we're talking about here is not about math. It is about static abstract members and interfaces, or static virtual members and interfaces. Now, that said, this math scenario for it is one that we really leaned into, because it's important when you build a new big language feature like this that you have a really strong scenario to co-build with it, so that to help us make sure we get it right, and also to justify doing the work. Alongside of this, alongside of the language feature, we built this hierarchy of interfaces implemented them on all our built-in types and made them available for you to implement. So you can also plug into numeric algorithms with your own types. And we did a few other things in the language that are specific to math, just to complete that scenario. One is that a thing that we have long shirked is the ability to have a special overload of a given operator for when you're in a check context. So you can put in, so you can see there are two overloads of plus here that have all the same types. They overload on the checked keyword on the second one, essentially. So that one is the one that gets called if you're in a check context instead of the other one. So up until now, only built-in types had the ability to to have operators work differently depending on the checked or unchecked context. Now that also is something you can build into your own operator implementations. Yeah. And another tiny little thing to notice here is that the checked one doesn't say abstract, and you can't see it in metadata. But the reason for that is that it's actually not abstract; it's virtual. It has a default implementation right in the interface. So these static members can have default implementations, just like we added for other interface members a few versions ago. So
C# 8 was that with DIMS and C# 8?
Yeah, 8 or 9. Yeah, I think you might be right.
Together.
Yeah. And so you can probably imagine the checked operator is implemented to call the unchecked operator by default, so that if you don't care about having a difference and you're implementing this interface, you don't have to manually implement both of them. You can just leave the default implementation of your checked one, and it'll call the unchecked one and do the right thing. So that's how it all kind of comes together.
That's awesome.
But
let's take a step back. Yeah, let's step right back to the I number again. Because there's some other things on here that are interesting and also not about math, right? And that's what's great about this feature is that, it's the whole static abstracts and static virtuals and interfaces is, again, it's just a brand new way of abstraction. In .NET 7, we introduced our own particular flavor of a domain-specific kind of implementation that uses this particular abstraction. That's our generic math interfaces, right? So you can do generic math, but you can do lots of things with it. And we took some advantage of that. You see some standard interfaces here, including this iFormatable one that's been there forever. And if you don't know what iFormatable is, it's the magic that makes toString do all sorts of formats, and you can make it do whatever you want. And so basically it's about taking an object and turning it into a string. But we've never really had an abstraction for the reverse of that until now, until we have static abstracts. We were able to add iParsable. Now, a lot of types had the members of this interface. This interface didn't exist until this release, but they had parse methods and try-parse methods. Like there's been for a long time, you could say int.tryparse, int.parse, but we've never been able to abstract over those because we didn't have the ability to create an abstraction that contains static members, right? So we could never say, yeah, what's the abstraction I can use? How do I define a method that takes anything that can be used with a try-parse method, right, or a parse method? And now we have that. And so this is almost the opposite of iFormatable, where iFormatable takes an object instance and produces a string. This can be called on a type, not an instance, on a type, given a string, and return an instance of the object. So it's kind of the inverse of that. It's what do we call this, Matt? It's a factory, right?
It's a factory. Yeah, you can see, and it's strongly typed as well, right? You can see, you saw the tself type parameter on a few things here, and you can see this shows very clearly how you use it. The tself type parameter is one that you give the interface when you implement it. You give yourself as the tself type parameter, if you will, because then your type will get substituted in the right places in the signatures of these methods. So you can see tself show up in both signatures. Well, one of them is off screen, but on the first one, you can see tself as the return. And that, of course, when int implements iparsable, then it implements iparsable of int, and now int becomes the return type of parse and the out parameter of try-parse. So that way you can thread the strong typing through the interface, even as the interface itself is abstracting over many different types.
Right, because we have other types in the BCL that have try-parse and parse methods, just like our number types, right, do.
Yeah.
And now you can write methods that generically take an iparsable of T, and they will work with those as well. So, for example, GUIDs, which aren't really numbers, right? Not exactly numbers. They certainly don't have addition operators, right? But they do have try-parse and parse methods, and so GUID and the BCL now also implements this interface. This is kind of like a poor man's serialize, right? But now you can write that abstraction that is, oh, I'm iSerializable. You know how we have iSerializable in the BCL way back. We have iSerializable, and it lets you, pass in, have a particular member that lets you kind of get the object data out of an instance and push it into some store. But you have to do the opposite of that. You have to write the special constructor, right? And now you don't have to, you can imagine a world where with serialization where you don't have to write that constructor. You can have an interface that has a static member on it called deserialize that returns an instance of the object from whatever medium, whatever format you're passing in as that was a serialization kind of format. So it's pretty cool. I'm excited to see what people come up with this feature.
And I think you mentioned before that this is sort of like a factory. These are factory methods, right? That's so very abstract. Looking at it very abstractly, these are examples of factory methods. They produce a new object from some incoming data, and if you sort of think design patterns, there are two classic factory patterns. One is static factory and one is abstract factory. Static factory is the one where you have a non-virtual static method that produces instances of the type that it's on. And then you have abstract factory where you try to make the exact mechanics of producing the value dependent on which type it is. And abstract factory is kind of icky because you typically have to build, if you have a hierarchy of types and you want to build abstract factories for them, you have to have a separate hierarchy of factories that in order to get that virtual behavior. And what you see here really unifies those two design patterns into one language mechanism. You can now have abstract static factories, actually. Like literally, that is what you're looking at. So it's kind of pulling that all together into one mechanism and letting you say, well, okay, my type, among other things, it implements this factory interface for producing me from certain data, whether it's a stream of bytes or whatever it is.
That's awesome. All right.
And we'll keep on bragging until you ask questions.
Yeah.
So it's going to get worse and worse.
And if you do have questions, this is a great time to ask. We're going to continue noodling with this demo, but we'll move on to something else.
Yeah, we probably hammered the abstract virtuals enough on our side, but yeah, any questions? We'd love to have them.
Yeah.
If you're still awake.
It's nearing 7 o'clock for them.
Okay, it's not that bad.
Yeah.
Okay.
All right. Well, then let's continue with this particular piece of code. And I like it. It's great, but it's kind of basic, right? Patterns are sort of the norm now. That's what all the cool kids do, right? They write pattern matching stuff.
Well, certainly patterns are great for a lot of stuff. And when did we introduce pattern matching? C# 7, I believe.
7. That's another example of a language feature that literally every release we continue to add functionality and expressiveness to pattern matching. Different ways to write patterns, different things to match over, conveniences that just we continue to evolve that, including this version. So I think many versions now we've done this. Yeah.
Yeah, this is sort of back to the roots in a way because I don't think it's a secret that pattern matching in C# and pattern matching as a language feature started out and is inspired by functional programming languages. And in sort of the classic functional programming languages that some of you might have been exposed to, like ML or Haskell or F#, hopefully, the sort of like crown jewel of pattern matching is list manipulation. That's sort of the thing that you always see examples for. But our pattern matching hasn't really dealt with list-like things, or hasn't had a particular way of deconstructing list-like or collections, collection objects. So this is where we finally landed on a good way to do that. That way we think is a really intuitive way. So we're going to implement this whole thing again, but using pattern matching, using list patterns, as we call it.
Yeah, and since we're going to be doing exclusive pattern matching, I'll go ahead and write this fully as a switch expression. So an expression that just does pattern matching to determine its various cases and returns results. That's all it does, but takes some input, kind of match on it and decide what the result's going to be, because that's what we're doing in a lot of ways when we're doing kind of breaking down lists, as it were. So we take an array of values, and the first thing you want to do, right, because right now it says we got to do things. It's giving us a warning. It says, hey, this doesn't happen. This isn't exhaustive, because, yeah, we haven't done anything, obviously. For example, the pattern underbar is not covered. I'm not going to do underbar because that's cheating, right? That just means cover everything. But there is one case that's obvious and first, and that's the case where we don't have anything in the list, in the array. And it looks like an array with the square brackets, but this is a list pattern. If this were a list of T coming in, or anything that kind of looked list-like, we'll support it with these patterns. So this is a pattern that means the empty list, meaning there's nothing inside. And for that, it's easy, right? We just return 0.
Not that easy, because we're generic.
Oh, yeah. Sorry, I can't. Oh, generic.
We're still generic.
I gotta say, we just returned 0.
Yeah. So we still have our green squiggle. I wonder, there must be some cases we haven't covered.
There must be. So we haven't covered the pattern of length 1. So let's go ahead and do that. And so I'm going to write a list pattern, and this time it's going to be a list pattern that contains a variable pattern matching simply one item. Okay, and in that case, that's also easy. We can return first.
Yeah.
Right. But now it says we need to do length 2, and so we're going to this is how we're going to fill the rest of this time if there aren't any questions. Right. We're just going to do list 2.
To expand painfully on that one, the var thing that you're writing there, var first and var second, they're patterns in their own right. Like this is an example of a recursive pattern. We have a few of those already. This is another example of a recursive pattern where you can apply any pattern recursively at that point. This is sort of saying, apply this pattern to the first element and apply this pattern to the second element. We're just using a very simple form of pattern that just gives it a name.
We're being very general about this, right? You could have in here the number 42. That's matching a pattern. That will match an array of 2 elements where the first element is the value 42, and the second one we're just going to name and put in a variable for use. So they are all this pattern matching kind of really composes together in interesting ways.
Patterns all the way down.
Patterns all the way down. So now, speaking of all the way down, we haven't done pattern of length 3 yet, and that feels like we're going to start getting a little contrived, and we're going to start seeing attendees leaving.
I vote that we keep going until we get a question.
All right.
No, I'm fine.
Challenge accepted. Okay.
But we're certainly you can see the problem here. We can't write one for every length because that'll literally take forever, or what amounts to forever. So we do need to somehow deal with the rest somehow.
Yep.
Like grabbing some things out and then holding on to the rest.
Yeah. So that's a good point. I'm going to call this the rest, and it's another pattern that can be used in list patterns, which is very similar in syntax to index and range expressions when we put range expressions in C#. 8. They were in 8. Yeah, it's hard. So, and that had a syntax where you'd say, okay, some start ... to some end, and you could optionally leave off the start or end. Similarly, we can do that here, where we can say, actually, I just want to get everything all the way up to the end, and we'll call it, and just like I did a range, and now it comes back to me as a T array, which is awesome. It's a form of slicing.
It is indeed, and not only is it a form of slicing, we'll get back. Maybe we should get back to that a little later. But yeah, it's extracting a smaller array, which we need to do something with the smaller array. But since we're sort of inspired by functional languages anyway, why don't we just recursively add all the rest?
There we go.
And now,
just to prove it, we'll just run it and make sure that everything is still good, and it still adds up to 12.3. And now we've introduced recursion.
That's all the testing we need.
Yep, that's it. And in fact, one of the things that's I find very interesting about patterns, and I love about patterns and switch expressions, is this exhaustiveness testing, right? We saw the warning up top telling us that, hey, you haven't covered this pattern, you haven't covered this pattern. Well, now because we're saying, well, we need patterns that are a pattern where it's just empty, pattern with just one, and a pattern where it starts with one and just give me the rest. Well, that covers everything, so there's no more warning, right? And in fact, if I bring this line, if I move that up, I'll get another really nice, useful feature of pattern matching and switches and the exhaustiveness testing, is that this has an error on it that says this pattern is unreachable. We'll never hit it, because it turns out that even if the array has one element, this pattern will match that, because it'll put that one element in first, and last will be the empty list. And we handle the empty list case right up here. And so when we call this where rest is the empty list, all this still works out. We don't even need that line. And it all still works.
Yeah, it's very that strong compiler checking on switches and switch expressions is turns out to be really useful. It just keeps you honest. It helps you make sure that you dealt with all your different shapes of things in a way that you can't really get if you have an if-else kind of nested if-else flow. Just looking at the thing and convincing yourself that you dealt with everything is hard enough as it is with if-else, and it's kind of easier to read through a switch expression here visually because things are just listed out. But also the compiler helps you if you forgot something. So it really, these kinds of multi-conditional cases based on shapes of data and contents of data are really come out beautifully in pattern matching, and list patterns are no exception.
Yeah, this is also an example of something that I think looks beautiful, by the way, but also is impressively different from the C# I was writing, 5 years ago even. Really, there's been what's capable in modern C# has really grown in these last several releases, and this is no stranger to that. I love this. The thing I don't love though, Mads, and it's the elephant in the room, and if anybody's a student on the call, they know this is slow as can be, right? Because, okay, we take an array in, and then we match it here, and we take first, and then we allocate a new array. We slice an array, getting back a brand new array that has all the elements after the first one copied into it. So we call recursively with that, and then we do it again, we do it again, and we do it again until we get to the very bottom where we finally have an empty array. But we're actually allocating like very irresponsibly.
It's quadratic in both time and space here. Yeah.
Yeah, the for each was better, right?
The for each was better from a performance standpoint. And it's worth looking at why that is, because the ... element there, which is you can have once in a list pattern, 0 or 1 of them, right? It gets whatever is between the first and the last individual elements you grab. That actually leans on that C#8 feature you mentioned with the indexes and ranges. It specifically, when we made that feature, we allowed for slicing. Like we made slicing a thing that was represented in the language, meaning that if a type had the right shape, the right members on it, you could slice it. You can, for instance, slice an array by indexing it with a range. You're essentially saying that means give me the array of elements 1 through everything.
1 through the rest of it. I don't know how big it is. Just give me 1 through the rest of it. And
yeah. Or you can say 1 through the rest but 1. You can. There's a from end, the hat thing on indexes as well. You can say, yeah. So this essentially discards. Discards the first and the last element. And we made a decision that this essentially relies on members in the BCL. And we made a decision with the BCL team, reluctantly, but probably the right decision, that slicing should always return the same kind of type that you called it on. When you slice a string, you should get a string back. When you slice an array, you should get an array back. And that's not always the most efficient way to represent like a subrange, but it is the one we'll use consistently, because otherwise things get confusing as a user of the API.
This is why we introduced span, right?
This is, yes, one of the reasons.
This is one of the big reasons we introduced span, where span is simply a structure that wraps around a contiguous array, right? It's kind of storing what amounts to a pointer to the first element that it is a span for in that span of that array, and a number indicating the length. And so this does exactly the same thing as if I had this, where it's producing, except instead of producing an array, it's producing another slice. And what's great about that is is simply changing the pointer and the length when I slice it, and it still wraps around the same array. So I don't have to allocate a new array. I just get back another slice, another span that from the original array.
Yeah, it's a narrow window onto the same bits in memory.
Yeah. I like the window example, because there's also read-only span, which is kind of like it's a window you can't reach through, but with span you can actually, it's like an array, you can set elements on it and all of that, but there's read-only span, which doesn't allow that. And so it's like a window you closed, but you can still see through it.
So we can use the span thing.
So if we go ahead and we say, let's do it here, let's make this a span. Let's get back to this code, and instead of taking us an array of t, we'll take a span of t. And now, when I hover over rest, you can see that has sliced into a span. So now we no longer allocate a new array every time. Instead, it's just moving pointers and ints around very, very efficiently. And so this probably is negligible, very, very similar to the performance that was there in the first place. But it looks very different. It really is a great example of the difference between writing an imperative function that does exactly what you say, one step after another, versus a functional approach where you more about manipulating the data and breaking it down to subproblems that you call recursively.
Yeah, and this example, I mean, I don't want to scare you with, list. I don't want you to go away saying list patterns are inefficient. Nope. They use slicing, and slicing is, you should be aware that slicing will do its best, but it'll return the same kind of thing that it's slices on. So if you use the dot thing in there with a pattern, you can actually just say dot and skip some things, and they'll just be ignored. But if you put a pattern there and capture the things, then that'll be done with slicing, and it's only as efficient as slicing on that type. So that's just something to be aware of, and in particular when you're being recursive, that can have some performance traps.
But the runtime span was introduced for exactly this reason, and it produces very efficient code. The runtime is very, very smart around span. So cool. That's fantastic. I like this feature a lot.
Yeah.
I started using it all over the place, and everybody hates code reviewing me now. So they're all still getting used to it.
They got to get with the program.
Yeah.
Any questions out there on list patterns?
So quiet.
Yeah,
Not even from Joe Kunk. Nobody.
that's fine.
Eric Gurney. Come on, guys.
We're very good at filling the time ourselves.
Yeah.
But we are kind of getting it's getting it's gonna get tough here. We have one more feature that we kind of queued up. Few questions came in now. We have one more feature queued up, and then we're gonna kind of run out of stuff to talk about. Can you have more patterns after the ... Good question. Yes, you can.
Because this is a pattern too, right?
Yes, but can you have more like individual element patterns? And yes, you can. It doesn't have to be the last thing. So you could say comma. Well, after the rest, you could say, oh, you want to do something else. I'll let you do it.
Go ahead. Tell me. Show me what to do. Tell me what to type.
After rest, put comma var last.
Yeah.
You can totally do that. So now
and
rest will.
Now we haven't covered length 1 anymore.
Yes. It all hangs
together. This is going to be at least of 2.
Yeah. So you get to put the ... wherever you want in the list. You'll just only get to put 1, because otherwise the pattern can't figure out which elements go to which of the 2. So that's the only way to kind of make it deterministic.
I could make it say something like this.
You can put any pattern.
You can use whatever patterns you want in here, right?
Mm-hmm.
That's a comparison pattern, right? That's a greater than. Make sure that but only when this element is greater than 23, right? You can do what you like. And still, we aren't covering length 1, so the list patterns are fully recursive patterns. You could have list patterns inside of a property pattern, inside of another list pattern, and you can really, Jim, you said it seemed like it would encourage cleaner code in some cases, or it could not if you go too deep.
Yeah. As with everything, you can overdo it
tastefully.
Yeah.
Yeah.
And it's also worth remembering in a switch that you can also, like, first of all, don't nest patterns too deep, because it just becomes unreadable, just like any code that's nested too deep. And you can also put when clauses on there, so you can just resort to simple Boolean expressions, which will let you put requirements on the case that aren't expressible directly as a pattern.
Yeah, the question is now, this is interesting question. Why don't I get a warning on greater than? Because this is a T.
Well, because it might be true. Mm-hmm. If the T
it might always be false.
Yeah, depending on the type, depending on the type argument, this could be true sometimes.
Yeah.
So
I don't remember where this is, so I can't really answer your question. I think they're in here, so I'm just poking around to see. Yeah, I would expect this to give an error because there is no operator for that. But
yeah, but this is but it's not using that. This is not the operator. This is the operator greater than. This is the pattern greater than. It is
pattern.
And a pattern. This just says essentially the pattern. A comparison pattern compiles to if the thing I'm matching on has the same type as the type of the thing in the pattern, that is 23, that is the type int, and it's greater than 23, then the pattern matches. And so this will fail for everything except an int that's greater than 23. So all other types coming in is just too bad.
So patterns often get checked at runtime. They do runtime checks against the types coming in. So if it happened to be that this was called on a generic, and it happened to be an int in there, good. Yeah. Good work.
And as a matter of fact, this was like one of the one of the cases for patterns that one of the first patterns that we introduced with the very first version of the feature is for type checking, right? You could have a case in here that says it could match a first element and check if it's an int, right? Just say open square bracket, int, close square bracket,
Yeah.
or int
I. Here we
I.
could say, yeah, we're only going to match on int. Right. Actually, I don't think I can type that there. I think I have to say span event.
Yeah.
Right. We're only going to match on that. Oh, I can't say span event. I don't know how to do it.
Span of you don't get to do that probably. I'm not sure.
You don't get to do that exactly like that. But yeah, you can use other types in here, and then it will match when those types happen to come in at runtime, right?
Yeah.
So yeah, kind of off in the weeds on this one, but it's kind of fun.
Pattern matching is so lovely, but it takes a little wrapping your head around. It's just a workhorse for more and more things. That really all that conditional logic that gets very gnarly and imperative, it can really clean it up and give you a much more declarative, simple overview of the logic that's being applied in the order it's being applied. So.
And in some cases, just be more efficient. That's the other thing. That's kind of like we don't sing as loudly as we probably should, but pattern matching often produces more efficient code under the hood, depending on the kind of the complexity of the pattern, than if you'd unrolled it and done the checks all by hand, because it can reuse variables on the stack and all of that, and reuse values, and so it winds up being actually remarkably efficient in a lot of cases. Even Stephen Tope said it produces better code in a lot of cases than he was able to.
Yeah, that's quite that's when you know there's some truth to it. It does this complex decision tree analysis, and it'll use heuristics as best it can to do things in the right order that has the highest chance of leading efficiently to the right result. And that's the kind of stuff that you would not, even if you could write it correctly, which I certainly couldn't, directly in code. It will be a nightmare to read and maintain. So let the compiler tell the compiler what you want, and let the compiler decide how to do it. That's the kind of the what, not the how. That's kind of the credo back from Link that we're reapplying here in pattern matching.
All right, shall we move on to our final feature?
Yes.
All right. Final feature is raw string literals.
Yes. We didn't have time to cook them. They're half-baked.
Oh, I mean, kinda, but not really. I mean, they were a surprise. When we first brought this in, this was first brought into the language design, the proposal. Cyrus first brought it in. I was like, this is ridiculous. This doesn't feel like real language, and I was wrong. It
was ridiculously
one of the coolest features we've done in a long time. Yeah. So, okay, let's do a little story time then. So looking at this code, how many of you have taken code like this and copied it off somewhere and said, well, I'm just going to paste this into a string, and it looks like that, right? Everybody. And you got to go, oh, okay, let me go through and escape all the double quotes, right? It's probably one of the most annoying things in C#, when dealing with that, especially because we're often, like, if you're writing a lot of unit tests, so often you've got a string literal or some piece of XML or something to kind of, to be used in the test, and or JSON, and it just gets in the way. All of this escaping drives me crazy. So we always said you could kind of fix that with a verbatim string, but that doesn't fix double quotes, right? You still have to escape double quotes, but with another double quote. You still don't get to write the thing that looks like the thing that I want to show up, that I actually want the content, right? So in this version of C#, we have made it better. We have let you do one more quote. Isn't that
This
exciting?
is a raw string literal.
Yep. And so now these aren't, if you look carefully, we had highlighted these before because they were escaping. But if I run this now, Just build and run, and you'll see that in fact it prints it with the slashes in it, right? So now I can remove them.
They're part of the content now. There are no
Yep.
escapes in a raw string literal.
Right. And so you delimit it with 3, because 2 already means something in the language, right? It means an empty string. And 1 obviously opens a string, so we had to go just 1 more, was the idea. And so now you can have, raw string literals. And what's really great about these, Michael, is that, speaking directly to you, is that these can they can also be multi-line. So I can go ahead and do this and make them multi-line without that verbatim bit. And there we go. And the way that works is that the opening delimiter has to be at the end of the line before, and then the closing delimiter has to be the last thing you see, and it has to be on the next line. It can't be part of the line above it. Now, what's also interesting about this, and this is the thing that I also write in unit tests, I've written in our unit tests all the time, because we write unit tests that are on C# files, right? So they take a lot of strings. And so you always have to write a method that says, oh yeah, and make sure I trim it, right? But this is pre-trimmed, okay? You will not get the line break up here, okay? Nor will you get the one down here, right? So if I run it, now we see that's what I have, right?
But there's more. You not only did the line breaks go away at the beginning and the end, some of the spaces went away, Dustin.
Yeah.
What's going on?
Look, the left justification. It's all the way flush on the left. And the way that works, this is such a trick, and that's why I was like, this is crazy when it was first proposed, but it's so perfect. So this last delimiter, depending on, it can be no further than the kind of the first non-white space character on the line above it, right? But if I move it back, and you can see, if you look carefully in the IDE, there's a little line being drawn. If you can see that, I don't know if it's showing up, but it shows where it's actually going to cut off the white space. So if I were to put it like here and run it again, you see there's a little bit of white space in front of it, right? So it defines how much of that white space to the left gets added, and it has to match. You can't go around mixing all the way to the left side with your tabs and spaces. You can use tabs, but you got to match. You can't kind of mix them funky.
Yeah, can't mix. But yeah, it's a slider. The end delimiter is a slider. So
that's an error.
Take it too far.
Yeah.
It's an error. It has to be aligned with the leftmost things.
Michael just asked the golden question: what happens if I need to have triple quotes inside? Whoops. Well, that's not going to work, is it? That's terrible, right? So, and this is again why I thought this language feature was weird. The trick is, Michael, just add one more around this outside. Just add one more than you need on the inside. So if you want to have 20 double quotes in a row, just put 21 on the outside and it'll work. It's great. So we give you an escape hatch.
Essentially the first line of set of double quotes tells the compiler how many to look for to consider the string done.
Yep.
You just have to beat whatever's in the content.
Yeah, you're telling the compiler how to count double quotes. Now, of course, this would not be useful if it did not allow string interpolation, right? Which is a fantastic feature. So I can put $1 up here, and that allows me to have interpolations inside. So I could put in 19 plus 23, and that'll print me out a nice. That's 2 prime numbers that add up to 42 in the middle, so they're perfect. And that works great. But Mads, what?
Yes, Dustin.
What if I want to put curly braces? What if I put an interpolation? Turn it into an interpolated string. What if I want to have curly braces in here? How do I do that?
If you want to have both so you can have either curlies in content by having no $sign, or you can have interpolation by having a $sign. But what if you want both? Well, just add one more. And the thing to add one more of is the number of dollar signs.
Dollar signs.
The number of dollar signs in an interpolated raw string literal tells the compiler how many curly braces it takes to open up and close an interpolation hole.
Right.
Anything
so if I
less
had
than
5,
that, content. And you go to 5 and it's a hole. Boom. And now if you want to put extra braces around it, you can put up to 4 extra.
Yeah.
Before they become a hole again, and you start getting errors by putting them around another hole. So there you go.
If I do that, well, then I get an error.
Yeah.
So
if
what's
you print
great about this? Yeah. It's a weird feature, but it's a sleeper hit. This is so excellent because instead of kind of making the string literal happy, now the content wins, and you have to tell the compiler what to do with it, right? We've kind of inverted the whole problem. So no longer are you making the language happy. You're telling the language, here's how to work with my content, and I think it's a brilliant feature. I wish I'd thought of it.
I really think you should run and print this.
Oh yeah, sure.
And out there, you can all guess like how many curlies will be around.
Well, it's got 4 around the outside, right?
Yeah.
Because that's what I wanted.
Yeah. And luckily, the colorization in Visual Studio helps you easily see what's content and what's not.
Now, let's be fair. Nobody's writing this, right? People are writing this, and they might have $2 if they want to add curlies into their content, right? But
yeah,
that's fine.
It's just so that there's no like arbitrary limitation. It's not like, I mean, at some point, if we wanted, let's say you wanted to test this with this program, you would quote this whole like buffer into another raw string literals, and you'd interpolate some things and so on. You can get to where 2 or 3 deep if you're being really sneaky and you're testing C# or something, right? But that's pretty much it for realistic scenarios, I think. It's just nice to know that if I need it, I can beat it.
Yeah. Though I will tell you that in VS Code for the C# TextMate grammar, which is all regular expression based, for the colorization, the syntax highlighting, I think we only went out to 4. We said,
okay.
It just seems like at that point, maybe you don't get good colorization. So, I think we went up to 5 for double quotes and 6 for double quotes and 4 for dollars.
Okay. Well, you can always add more if people complain.
Yeah. Okay. So, and yeah, Joe, I saw your question in there, Joe. That do the interpolations all have to be on one line? Of course not. Interpolations, this is a multi-line literal. This is a multi-line literal text. So, and you could always do a verbatim and interpolated verbatim string before, and they could also spread across multiple lines.
So this means we can use more complex expressions now, right?
Sure.
Yeah. This is in fact a new feature, Dustin, that interpolations can spread over new string or over multiple lines, right? Yeah.
Yeah. Unless it's yeah. So it's a new
that's
feature.
not just
I can put a list pattern in here.
Yeah, and it's not just in raw string literals. We did that for all interpolation. It was a weird limitation before, kind of just missed it on the first go, I think, and we just went ahead and fixed it.
Yeah, I could do like X switch goes to, and I could go ahead and start writing my interpolate, like my switch expression with my list. Okay, then we'll do we could start doing that kind of thing in here.
Okay, but that wouldn't pass code review.
No, it probably wouldn't pass code review unless it was like really cute. It'd have to be very, very cute though.
Yeah, it has to make everyone happy.
Yep.
I have a question about just to clarify something you said on trimming the string. So between line 14 and 15 is a new line, right?
Yep.
So
and there's not in the string, and it goes all the way up and slices or chops off the white space all the way up to where that dark line is.
Okay. So the string will be, the first element will be a space. The second element will be that.
If you want a new line, you just add it.
Okay. And then my other.
But after the delimiter, you're not getting the cost of that extra white space that now you have to go deal with. We assume that what you put in content is what you want. and you've defined where it starts with the ending delimiter if you're on multiple strings. And so if you do want a line break at the top, you can still add it. You're just not going to have the cost of that extra line break, which is most of the time probably not something you wanted.
Yeah, and then at the very end is the last character in this string literal a new line, or is it the right bracket?
It's as if you did a trim on it already.
Yes, it's a right bracket.
Yep.
And it's worth what was I going to say? It's worth calling out also that you've seen, or to remind you, you've seen two versions of raw string literals. There's single line and multi-line. And for single line, they're both beginning and end have to be on the same line, both delimiters. And for multi-line, they have to be on different lines. So you can still make an empty string with a multi-line literal.
Right.
You just put them on subsequent lines with nothing in between. But it also, multi-line literals also solve a slight little problem that single line literals have if you want to end the content with a double quote. So what Dustin has there has no new lines in the produced string, because the first one gets elided, the last one gets elided. But now he can put quotes around Joe rules because they're not getting glued together with the beginning and end delimiter. So if you so whenever your single line raw string literals run out of steam, even for single line output strings, you can always fall into double or into multi-line ones and get it done there.
It's a cool feature. Yeah.
Yeah.
I'm a fan of this feature. It was, I'm kind of curious where we're going to go. We've talked about some fun things along with this that start to look like GitHub Markdown with 3 backticks. Well, you got 3 quotes. I wonder if you could put something after that.
Yeah, it's been proposed for the multi-line ones that you could put sort of like a language delimiter. There's like a free space there. But
there's room to do this, and then maybe get the IDE to colorize it differently, or the string inside. There's talk of that, or maybe even more appropriate, right? Or XML on the next one. We've talked about that sort of thing. I don't know if we'll get there, but these little string literals have captured our imaginations.
Yeah. They were the design meetings were ones where we would all leave with smiles on our faces. It's just, it was coolest. Okay. See, there you go. Save the best for last. Yes, we created the first new abstraction mechanism in C# in 20 years, but the best is the raw string literals.
It's like I don't have to trim my string literal like a, I can just,
No, but it's So with that, I think we're sort of out of things that we planned to talk about.
Yeah.
And we're also an hour and a half in. So for those of you who planned on that time, you got it all. We made it through. But if there's more like, questions, comments, I haven't checked with Dustin, but I have time to hang out a little longer. And feel free to, fire away. We can wrap it up if you feel like. So it really is up to you now.
Yeah, in addition, there really is no time limit now that it's virtual, so we can go until whenever. So if anyone has any questions or comments, feel free to jump in.
I just want to say thank you for doing this. This is great.
Well, thanks for having us.
Yeah, you're welcome. We're happy to be here.
Yeah, and great questions along the way there. Even though we teased you, those were really good questions, and I hope you all have fun with these features.
Yeah.
Actually, I do have a question.
Yeah.
So back to your pattern matching example, when you were playing around, you had a pattern that had like 3 terms in it. So you had like,
This one?
Correct. So the third term, because you don't have a variable name, it will just throw away that value, right? Okay.
Yep. It'll test it.
It will match it. It will test
see if
against
it can match it. Yeah.
Yeah.
Okay, just making sure. So you could put a variable name in there.
Well, for some patterns have variable or can have variables in them, and some don't.
Yeah.
You can also actually combine patterns with and or. So you could say greater than 23 and var x if you wanted to test it against 23 and also capture it.
Oh, so you can't. Okay. So on line 8, I was thinking that you would just put after 23, you would just say x. So the syntax is what you described then. Wait.
Yeah.
Right. Yeah.
Not all patterns allow a name to be placed after it.
Right.
So you'd say ampersand var x.
Actually,
what I would say is this:
the word and.
Oh.
Yeah, which is a pattern. We have and or patterns, which are not, they are matched patterns within the decision tree.
Okay.
It's a whole thing why we chose to use words instead of reusing the ampersand and bar syntaxes. Part of that is the other main place that you use patterns is in is expressions, right? So you can say, essentially, you can say something is int x and greater than 23, and it's
result up here is a double, so I could just say is greater than 23.
Yeah, but then if we put ampersand after that in your if condition there, then no, in the one in the if
one? Yeah.
Then you can see that. So after the 23, the 23, then in order to put another pattern, now it kind of gets ambiguous. Are you taking the Boolean that comes out of the is expression and ending that with something, or is this part of the pattern that is applied in the is? It kind of gets just very confusing. So we decided, okay, different syntax for ending and oring patterns together as opposed to ending and oring expressions together. That's the background for that.
I love it that this will also tell you that this could never match. That's because it goes to this decision tree, right? But I could write this and have it kind of be backwards. It's greater than 23 and less than 42, and yeah. Patterns are cool.
Yeah,
they're cool.
I think,
and they've gotten exceedingly powerful.
Yeah, they will take over the world someday. We should all watch out. They will be our
them and ChatGPT.
Okay, so
speaking of which, sorry to interrupt, with ChatGPT, so will there be any incorporation of that in future versions, just out of curiosity, with IntelliSense and other code refactoring tools?
I mean, there already is like whole line completion that's AI produced in Visual Studio today. And so maybe that goes more chatbot like, because the great thing about ChatGPT is you can say is instead Visual Studio is watching as you type, at least in like I can't even remember. I think it's in Community as well, Community editions. But the latest versions, they kind of print ghosted text that suggests the next thing you might want to type. And there might come a chatbot at some point where you can then query questions and say, okay, based on my current context in my code right here, write me a binary search because I don't ever remember how to do that. Right? I bet that's coming. You're asking, will that ever come? We don't know. But
yeah, we
I bet it will. I bet it will, right? That seems to be able to ask those questions or to ask questions about my code, and that sort of thing. And because to be clear, one of the things to be mindful of is that ChatGPT is an audacious liar. It makes all sorts of stuff up, right?
It has perfect
I could very easily get it to write me a resume that has all sorts of accolades that I didn't even put in there, and it just made up because it sounded good for somebody in my field, right? So it's audaciously lying all the time. So just be careful about that in your code. At least, with ChatGPT 3.5.
But they're definitely, I mean, they're already, so Dustin mentioned it's called IntelliCode, right? Where you get these smart completion suggestions in Visual Studio. And of course, there's Copilot as well from GitHub, which is even more sort of wildly predicting, not just line by line. My first experience with Copilot, I had just turned it on because it was sort of like a Microsoft-wide, please turn it on so we can get it tested. So I hadn't even thought about it being in my Visual Studio. Somebody wrote me a snippet of, or sent me a snippet of Python code and said, I just wish the equivalent of this would be as simple and beautiful as in Python, in C#. And I was like, what do you mean? This could be written beautifully in C# as well. So I went over to Visual Studio. I typed // and put // and put the Python code in a comment. And then Copilot wrote me the C# program because it knew from the extension that this was C#. It just wrote me the thing I was going to write to send back to the person. So there are some really impressive things just waiting to be exploited or already being exploited in various ways. But as Dustin says, the danger here too, of course, code is less subtle than natural language. So we might be able to get closer when it comes to like reliability, but sometimes using these AI ones, they just spit out some really random stuff, and sometimes it's a new way to get bugs.
Yep, you can already ask ChatGPT things like write for me a Roslyn analyzer that checks for these problems, and it will write very good boilerplate Roslyn analyzer that you can take and copy into it and finish up, or correct. It's pretty impressive.
Yeah.
Of course, I'm only ever asking it for horror movie scripts. So, write me a horror movie about geometry class, or write me a sonnet about, Mads Torgersen or something like that.
So that was a long answer to a short question.
Yeah.
Oh, no, it's all good. So here's a question that ChatGPT might not answer, and for Dustin. George House, Coffee Amici, or Grounds?
Oh, I was just typing. So, well, I mean, why do I want to go there? So my dad lives in Findlay, and I go visit every so often, and it's very convenient to walk to Coffee Amici, which is downtown, though, right? And so, but if I want to go off the beaten path and go over to like University of Findlay, then it's George House. And George House has a cooler kind of college vibe, which I'm into. For me, though, Grounds for Thought has all of that, and they roast their stuff and I can smell it in the morning. And they have the big used bookstore, so I go there for different reasons. I find that Grounds for Thought for me excels for conversation when I'm sitting and meeting people, that sort of thing. Just depends. Okay. But I prefer Grounds. I'll give it Grounds, and I'll say Grounds George House Coffee Amici if I'm looking forward to coffee.
Very good. Anyone else with questions or comments for Mads or Dustin? All right, I take that as a no. Right. Before we go, just have a couple of wrap-up announcements. But first of all, thanks, guys. Highly appreciate it. Very well done, as always. So thanks to Mads and Dustin for joining us tonight. And hopefully you can mark it in your calendars, January 2024. I know it's a little bit ahead of time, but, got to plan ahead for these things. So I would love to have you back again. Appreciate it. So if I may, I'll take back the presenter and go through a couple of wrap-up announcements. And so in the chat window, I pasted several links, and we'll go through them now. So for YouTube, the presentation is being recorded and will be edited in a couple of days and then uploaded. So if you would please subscribe to the channel, and you'll get the upload notifications. And as far as tech events, which we'll cover in just a little bit, that's also going to be posted on my blog. And as you might have guessed, the link is also in chat. Last but not least, the feedback evals. We want to provide Dustin and Mads some constructive criticism. So please fill out the eval form, and then we'll use that for the raffle prizes. For those that joined us after the start of the meeting, a special offer from Manning.com, 35% off on a selection of books that are accessible with the link provided in the chat. And the discount code is MTPCLEC21. With regards to events, so we got a few user group events that are happening on January 31st, which is this coming Tuesday. The Capital Area.net user group, which is in Virginia or the DC area. And I will be speaking there about adding machine learning to .NET applications. So if you're interested, you can join us at that meetup. And these links, by the way, are posted on my blog, so you can just simply access that link in the chat and go join all those meetups. On February 2nd is the Twin Cities.NET user group, and all these groups are meeting online, by the way. But within the Twin Cities.NET user group, they're going to be discussing gRPC and other web services. And that's happening on February 2nd. On February 7th is the Ohio North Database Training Group. And that is a hybrid type of meeting, online / in person. And then February 8th, we're going to have the Azure Cleveland user group. And then February 23rd, which is the fourth Thursday, will be the February meeting of this group. Speaker has not been assigned yet, but certainly working on that, and we'll have one lined up before that time. As far as conferences, January 28th is Data Toboggan from the UK. And because it's in the UK, the time is going to be a little bit off, but you can join a variety of those sessions. Chances are, if you work with code, you're also working with data, and they cover a variety of different tracks, so there's something to learn from attending that conference. Free of charge, online, and it should be something beneficial for everyone. Always like to ask, as far as job openings, Tech Systems always has job openings available at techsystems.com/IT-jobs, but always like to ask who's hiring and who's looking for work. I assume Microsoft is not hiring at this time. Is that correct, Mads and Dustin? Are they still with us, or did they leave?
No comment.
No comment. All right. Fair enough.
We don't have any specific positions that we know of. Let's put it like that.
Well
Also,
said.
not a manager. Have no idea.
All right. Anyone else looking for work or looking to hire someone? If you would please make yourself known, either in chat or verbally, or you can even email me afterwards. All right. And with that, contact information. If you need to email me, snasser@NISTechnologies. You can also find me on Twitter @SamNasser, and the link to my blog once again. And if we're not connected on LinkedIn, I invite you to do so. So with that, thank you again to Mads and Dustin. Thank you all for attending, and look forward to seeing you all in February. Good night, everyone.